Hi. Yep. Finding sine, cosine, and tangent can be tricky, but you got to remember your reference angles in the first quadrant. So I actually have it worked out here, but I want to talk you through it, make sure you understand what's going on. I think that you meant for t to be negative 3 pi over 4, correct? I'm going to go with that. So the tricky part's the negative. But it turns out that if you think about a negative angle, that means it rotates backwards, right? Clockwise. And if you went negative 3 pi over 4, where would you be sitting at? Well, let's think about this for a second. So I have the x and y axis here. And I know this is, let me see if I can write this. This is 2 pi, right? And this is pi, and I have to go back negative 3/4 pi. So I know I'm not going all the way back to pi. So 3/4 pi would be, if I can get my things going here, would be going right there. And so your actual angle that you're looking for is that angle. Now, the only reason we really care about that is it's going to affect our sign on the excuse me, the sign on the final answer. Will it be positive or will it be negative? And we'll address that in a minute. The important thing to know is you've got to figure out negative 3 pi over 4. What's the reference angle? And when it's in radians, it's super easy. It's just the radian over the bottom. And that's pi over 4. And so that's what I have here. You can think of it as 45 degrees also, which might help you because if you don't have that pi over 4 memorized, what I did is I made a right triangle on the unit circle. So my hypotenuse is 1. And then I would have a 45, 45, 90. And I got the two other sides by just using the formula for 45, 45, 90. So the two sides would be root 2 over 2. If you need help with that, please ask me and I'd be happy to show you that. So now we're ready to find sine, cosine, and tangent of that 45 degrees or the pi over 4. So I'm going straight back to geometry, trigonometry. Sine is opposite over hypotenuse, so that's the opposite is root 2 over 2 over 1. And then I just simplified that to root 2 over 2. The cosine will be the same thing because the adjacent side is the same, so it's root 2 over 2 over 1. And then the tangent's opposite over hypotenuse, and so we're going to take root 2 over 2 over root 2 over 2, and that cancels down to 1 because the top's the same as the bottom. Okay, so now let's worry about the sign. We know what the numbers are. But we're over here in the third quadrant. And remember then that this would be, the y-axis would be negative. And the x-axis would also be negative, right? And if you remember then, if I actually, let's do it this way. If I built the triangle out from the third quadrant here, then let me just put the angle in. The 45 would be right here. Then when we think about it, this side would have to be negative, right? Negative root 2 over 2. Because the number's not going to change. Because the x would be negative, right? And the y value would also be negative root 2 over 2. And then the hypotenuse is always 1. It's not ever going to be negative. So the x and the y are negative, basically. So now how is that going to affect my answer over here in the pink? Well, the sign then opposite should be negative root 2 over 2 over positive 1. That would give me a negative root 2 over 2. So that's the answer to the sign. Cosine would also be negative root 2 over 1, which would make it go negative. And so that gives you negative root 2 over 2. And the tangent opposite, and excuse me, I put hypotenuse there, but that is wrong. That should be adjacent. I apologize. So opposite over adjacent, well, they would both be negative, right? And a negative divided by a negative would be positive. So the point of this is to get the numbers, you think about the reference angle. Figure out what it would be in quadrant 1 and get the numbers there. And then the sign you have to think about in where your triangle will be, which quadrant, and figure out which would be positive and negative. Okay, well, I hope that helped you. If you'd like any more help on this, look me up and I'd be happy to help you one-on-one. All right, good luck with this.